At Microsoft, security is job one for a lot of what we do. And in previous recordings, I've mentioned it was one of the fundamental shifts as we moved to Azure. We are secure by default and we assume breach. There's a number of terms that we'll look at and we'll point out security. And so this is, in our network series, how we look at from a network security perspective, dealing with managing the network traffic in one specific area. Now this is going to be very familiar to most of you who've worked with firewalls, but we're going to introduce a topic called the network security group. So let's get into this. I'm Bob Tickleman and I'm excited to be your guide for this lesson. I mentioned that the NSG is similar to other network services that you might have used in the past in traditional networking. A network security group is a feature of Azure that gets deployed along the subnets and the VNets that we worked with and talked about in a previous recording. So we're going to dive into the NSG and show you how you configure it to get that network security in that traditional manner. Now, one of the benefits of an NSG is they're free. And I would suggest that you use them extensively throughout your internal infrastructure in Azure. As a free resource, it would be a waste not to use them, even if you don't highly configure them. And we typically take the more expensive resources. I'll say more expensive because anything's more expensive than free. And things like Azure firewalls and app gateways, which have a cost to them, do a similar feature, but they have that cost that's associated with them. So we typically look at those usually in a public-private ingress-egress. And so I'm going to be doing in a whiteboard session where I'll talk about using an NSG on an inside subnet that you're working with, which is a real good example of where you might want to use them. So let's get into the topics. The Network Security Group, or NSG, is a characteristic that resembles what you would typically have done in a firewall with your firewall rules. It's going to do in the OSI model, that 7-layer model that most of you probably are very familiar with, on analyzing information. And we take a look at where it does that analyzing. So in the OSI model, we take a look at layers 1, 2, 3, 4, 5, 6, and 7. We're not going to get into all the layers, but the NSG, or the Network Security Group, is a layer 4 analysis where it's going to be able to analyze information. Now, it's not going to do all of the things that a firewall will do. So I would like to say that this is firewall light. So it's not going to be able to do deep packet inspection. It's not going to be able to look at the traffic specifically. It's kind of a brute force tool that it basically just looks at some of the characteristics of source and destination ports. It's going to take a look at the port and the type of protocol that you're working with. So some very broad spectrum network capabilities to be able to shape and control traffic. And so this is going to be done through the Network Security Group rules that you'll create, and that processing is very similar to what you would have done in a firewall. Just know that that packet filtering and some of the deep inspections that you could have done with a firewall, you're not going to get here. So for free, it's a great way just to actually shape traffic. And to do that, let me just talk about that at a whiteboard, and we'll come in and show you how to configure this. So in a previous recording, we talked about this term called a VNet. It is an address space that you use to define a range that you want to then be able to allocate to some resources. Now that VNet is broken up into one or more subnets. I'll call this my front end. I've got my business tier. And I've got my data tier. In that, I could then subnet was the term. So we have our VNet as the address space, and then we get our subnets down here. The subnet is going to then be broken up into these subnet addresses. So I've got my 10.2.1.0/24, 10.2.2.0/24, and my 10.2.3.0/24. So those are my three subnets inside of my VNet. Now we mentioned that IP addresses, I'm not going to go through all of it. Not all of them are available to you. Remember that TCP/IP is going to take 2, so the first and the last one in this range, and we're going to take the first 3 available are going to be used for Azure resources for DNS and DHCP. So in all of these cases, the first one that's going to be available in this example would be the number 4. By default, we're also going to create a default gateway at each of these subnets, and that's where it's going to get the address of 1. So we've got 10.2.1.1/24, 10.2.2.1/24, 10.2.3.1/24, AZ-104/24 as the default gateway. And think of these as little routers that are now going to be able to shape the traffic. By default, all of these have a default route that would allow all the subnets in the VNet to talk to each other. Covered in another module we talked about in networking in general. So that is what's going to happen by default. You could define a specific route if you wanted, but it doesn't prevent traffic from flowing from one subnet to another. So what we have is the NSGs that we could then deploy. I'm kind of draw them as a shield here. I'm paid for my technical knowledge, not my drawing knowledge. So the NSG is going to have a set of rules that will allow traffic in or out of the subnet that it's protecting. So now if I wanted to shape traffic that said maybe I've got my front end, my end user experience that users are coming to gain access to maybe a web front end or something, I want the output of this traffic only to speak to the business tier. I do not want the traffic coming from the front end going to the data tier. So I want to be able to control that traffic. And so what I could now do is through the NSGs be able to shape the traffic on either an inbound or an outbound and either allow or deny traffic. Now this is going to go back to a general rule that we talk about, that there's several general rules that you want to remember at Microsoft. One, child objects inherit things from their parent in many cases. And in a security rule, permissions are cumulative with the exception of a deny. And so what you're going to see in here is if you don't have a permission defined on the NSG by default, you'll see that there's some default permissions that are happening in there. The rules are configured so that nothing will happen until it hits a rule that meets the criteria that the rule defines. And with nothing in there, you're going to see that the traffic, and I'll get to the rules in just a few minutes, that allows for this default communication of all the subnets in a VNet can talk to each other. So I need to get in and now change those by putting another rule in to say, I want to have maybe outbound only go to a specific location. Now I could also have an NSG. I could potentially stop it from coming out and going to subnet number 3. But I could allow it to come out and go to subnet number 2, their business tier. Now this gets into a designed requirement or criteria that you might have. I know how I would do it, but I could restrict the traffic outbound from NSG number 1, the front end, and stop it from going to NSG number 3. I could actually create the rule at NSG number 3 and stop it from coming in from subnet number 1. Or you could do both. Now, I'm a big believer in what's called trust but verify. So I'm going to trust that subnet number 1, my front end, is stopping outbound traffic to me as subnet number 3. Or I could verify it by saying, listen, I'm also going to make sure that what happens is if they delete that rule for whatever reason, I still have a block that is going to stop it from coming in. So these become design decisions. These are free resources. I might be tending to kind of err on the side of caution and potentially have a rule potentially to stop outbound as well as to block it on an inbound. So that's your choice. And when we get to the slides again, you'll see that you have the choice to stop traffic at the inbound and the outbound components. Now, typically, NSGs are going to be at the subnet level. The other place that you can put an NSG is at the network card level in a resource itself. So there's 2 levels of NSGs that we can be working with, one at the subnet itself to stop all traffic in or out, and at the actual device level, you have the capability to stop it because maybe you've got specific resources in that subnet to work with it. Now, we're going to be introducing also another topic in another recording called the Application Security Group that looks at a way to do this on a broader scale and maybe span multiple subnets in multiple VNets to be able to manage an application. But that's the concept of an NSG, a free resource that you could now use to shape traffic, not just using the UDRs or the user-defined routes, but getting into the technical blocking of the traffic so that it actually cannot communicate in or out to specific locations. Let's go back to the material. So as a resource, the NSG is something that you can configure either by itself and pre-build them and then allocate it to the resources that you wanted to have them be assigned to. So that, remember, they can be assigned at a subnet level or at a network interface card level. So you can build the NSG and then maybe use it because maybe it's common for a broad range of an application that might be deployed across multiple regions. So I need to have the same NSG at all deployments of that, maybe through US West, US East, through Europe Central, through Asia Central. So you've got multiple deployments, but I want the same rules in this global application. I need the same rules consistently deployed. Whether you use a template for that, we did that in another recording, I could now have an NSG pre-configured and then just deploy it along with the resources if I wanted to. Now, another thing that you could do is you can build the NSG at the time that you build the VNet as well. And so as a default configuration, if you don't go into the networking tab, and I'll do that in the demo, you can actually have no NSG assigned to it and only deploy it after the VNet and the subnets have been configured. So here's an example of what the NSG rules are going to look like by default. It's a bit of an eye-winking moment. For those of you who saw the introduction, I talked about if you're preparing for an exam. This is the kind of information. Don't know what kind of question it might be, but you want to remember this kind of information. Charts, default values I talked about. This kind of information may come up in an exam to say, you're trying to protect a network interface and you wanted to be able to do that. What would be the default action? And if you don't know what the defaults are, you're going to have a hard time answering that question. So this is the default configuration when you build an NSG. Now you'll see that we have a wide variety of rules that we can work with, and the default number that we start with is 100. We can have any number between 100 and 65,000 that you can now build. Now I would tend not to go to 100 and then have one at 101, at 102. You want to make sure that you have enough space that as your networking requirements grow over time, you've got some room to insert things without having to renumber them. So I'd have a numbering system that I follow. There's a number that are available if you want to do a search on the internet for what might work for you, but you may want gaps of 10, 50, hundreds. And maybe you've got specific types of rules that you want to have and have a numbering system that you follow. But make sure that you give yourself some growth room when you create your rules, that you just don't have them numerically sequenced one right after another. Now, what the rules are done is they're processed in the order of the lowest number, or what is called the highest priority. So the lowest number or highest priority, it goes through that list till it finds one, either to allow or deny. I'm going to have a deny at 110, and I'm going to have an allow at 100. So I've got an allow, and I'm going to say I'm going to allow 3389, which is the RDP port that you might be familiar with, that says if it's 3389, allow it, but everything else, if it's port 80 or 443, I'm going to deny it. Every other port, don't deal with it. If it's 3389, it's the first rule, it gets allowed. If it's port 80 or 443, it's going to be denied. And any other port, 5000, 8500, whatever the port is, any other one is then going to flow through the rest of the rules until it starts to hit the default rules. If it's not any other rules, not 3389 or it's not 80 or 443, it then gets down to 65,000. Allow VNet inbound from any port to any port in any protocol from a virtual network to the virtual network. So that's by that default configuration that allows all communications on any port, that if there's no other rule that stops it, that is going to allow all the subnets in a VNet to communicate to each other. We then get an Azure load balancer on any port, on any protocol. If its source came from the load balancer to any destination, it's going to be allowed. So we've got that default rule. And then the default rule is anything else is going to be a deny. So that's the default configuration for, in this case, the inbound ports, and a very similar configuration for the outbound. So know what the defaults are. It's going to allow all communication, in this case, from any other subnet in the VNet. It's going to allow any communication from any other VNet to your VNet, and we're going to talk about that in another recording. So if I have two VNets that end up getting what's called peered, I'm going to allow all the subnets in that VNet to talk to all the subnets in this one. That's the default configuration. If you have other Azure resources like an Azure firewall, it's going to be allowed in by default. And if you want to shape that, you may want to stop again from the public-private ingress egress from that firewall. You may want it only coming to the front end of your VNet and not to the back end or the middle tier. So all the different ways you might want to configure that. Here's the diagram that we talked about, the two locations in which you can assign the NSG itself. So we've got one at the subnet level, and we've got one at the NIC level. So the subnet is actually NSG number 2. The NIC is for NSG number 1. You have to have an allow at all of the places to allow traffic to come in, to have it flow through the NSG, to hit the network card, and to flow back out. If you put a deny at any one of those 4 locations, if I put a block here, an NSG to stop at the network card, it would flow in and be stopped at that point. You're going to see that we have the capability of doing an analysis of what the effective impact of the multiple NSGs that might be applied, of where the block might be coming, because the block in this case is coming from an inbound rule on the network card. It might be based on an outbound rule at the subnet. So any one of these combinations is going to create an effective block. And it might be hard to troubleshoot because what the response is from TCP/IP, you're not going to be able to do that deep packet inspection. You're not going to do packet sniffing, dropping things on the wire that you might typically do to troubleshoot this. But understand that we've got NSG analysis rules capabilities to determine where that block might be taking place. When you take a look at creating the rules themselves, you're just catching up on things that I've already said. The rules are processed from the highest priority, lowest number, and it goes through them sequentially till it finds one that actually meets the requirements. Once it meets that requirements, it stops processing. It's not like it goes through all the other ones. And so you want to make sure that you've put them in the right order. You might actually have to flip things around. I often see that as the case. Someone goes, oh, I want to block everything else after it gets 3389, but it might be a lower number. And because you've blocked everything except 3389, you might not get to another one that is blocking everything, and you're wondering what happened to that traffic. So make sure that the order and the effective processing of them is going to generate the results you're working with. We give you lots of ways to deal with this. We talked about it compared to a firewall. There's no deep packet inspection. It's basically looking at ports. It's looking at protocols that you're working with. We can look at general services, and so we don't have to get into just TCP/IP. You can say if it's coming from a VNet, is it coming from this Azure service like firewall? And you'll see that in the configuration of the rule itself. The ASG, or the Application Security Group, is another way as a software-defined layer to be able to do this. It's pretty easy to understand the NSGs at the subnet and at the network cards. So let's go to the whiteboard, and I want to see how an application security group gets applied. So we understand that at our VNets, and we've got our subnets, and I'm going to use this same example that we had before. I had my front end. I've got my business tier, and I've got my data tier. We had NSGs that applied at the different levels. We had NSGs that you could have at the subnet, and you could have NSGs at the network card level itself. Well, that's great, but in these examples, I've got 251 IP addresses or devices that I could assign to each of these subnets. There's quite a few devices that are in there. Well, what happens if I needed to allocate a rule to maybe half of them? So I'm going to have 128 of them that are going to be used for something /video, and I've got one for /images. So I've got 2 different services. Maybe I've got a publicly available resource, maybe something internal, however you want to do this, but they live in the same tier, in the same subnet, but I need to be able to distinguish them en masse. I don't want to have to go through and create. I could create an NSG rule for the network cards for video. I could create an NSG rule for the NICs that are images, and I could deploy them 128 times, and you could do it through scripts, so it could be pretty consistent. But now you're still managing 128 deployments. If I needed to make a change, you would have to go through and then make that many times. What you're going to be able to do is in the application security group, I'll use the color purple to be able to now, maybe I need to have a set of resources that spans potentially multiple subnets in the VNet and possibly even multiple subnets across multiple VNets that you're working with to have an NSG applied to the application security group. And so they're treated as an application group and not individual network cards or subnets themselves. So we have that layer of obfuscation, fancy word, that says I'm going to be able to take it from that standard method and be able to add another layer for processing. Very similar to what you had with the regular NSGs, you're going to have rules that are processed in that order for inbound and outbound traffic that you're dealing with, that you could now assign it to a group of devices or resources as an application security group. We also have the ability to work with this thing called a service tags. Now, service tags are slightly different than the tags that we talked about in another recording. Early on in the recording series, we had one where we talked about when you build resources, one of the things that you could do is apply a tag to the resource, something like maybe a cost center or what department it belongs to, or maybe who's the person to contact about the resource. So you can have up to 50 tags. Now, a service tag becomes a resource grouping that you're working with that's different than the application security group, the ASG we just talked about, that you can now have the tagging of. It's not a separate set of rules, it's a capability in the definition of a rule of what kind of resource do you want to actually tag that resource to. So you could see, remember we had the ones for if it's coming from a subnet that you're already working with, that was a tag from a service tag inside of Azure. So the Azure services could then be tagged as a capability to identify if it's coming from that Azure service, I want to grant it capabilities to either block it or deny services to it. Let's go over to the demo and take a look at creating a network security group. So I've already got a number of resources built that I'm going to, first of all, create an NSG, and then I'm going to go to an existing resource and be able to apply it. And we'll take a look at the pre-built resources, and then I'll build an VNet, and you'll see where I can actually do that and have the NSG be part of the VNet build process. So I'm going to come up into an NSG. You can see that I've got a list of NSGs that are already been built. These were already part of a build process of the resources that have already been deployed, but I'm going to create a new one here. And you'll see that it's a pretty simple little, I come back into my demo resource group and call it AZ-104 demo. What region do I want it to be deployed to? Now you can deploy it in this region, but it could be used across your resources in Azure. I can have a tag I can create. So there's not a lot that I can work with. It's not going to build the rules. It's going to just create it with the default rules that I would then be able to go in and modify. So I'm going to go to the resource now. It's just a brand new NSG, and it has those default rules that we took a look at. So I'm actually going to be able to get into the inbound rule. So I'm going to create an NSG rule. I'm going to have it from any port, source ports, again, any, or I can go in this case, 3389. What is the destination? I can go to IP addresses, service tags, or application security groups. What is the destination port? In this case, it's going to be 3389. What protocol that's going to be used, I can specify it. Priority, I'm going to call this AZ-104 demo. And there's my AZ-104 demo. Now I'm getting a warning on this, talking about port 3389 if you get into it. Hopefully you're all familiar. That's the RDB port. But any other protocol other than 3389 would be past this rule. No other rules. It would then have to come up against these three default rules that we're working with. I'm just going to say OK here. I'll save this. Now I'm going to go back to the resources that I already have. I'm going to come into a connectivity resource group that I have. And you can see I've got a bunch of network resources in here. I've got network security groups. These were built along with each of the VNets that I built. Let me get into one of the virtual networks. So here's a virtual network that I've built in what's called a hub and spoke topology, where I've got a central hub location and I've got 2 spoke subnets that are off of this. We're going to cover in another recording how that's done, why you might do something like that, and using a feature called VNet peering. But I take a look at my address space. I've got my subnets that I have. I've got a number of them in here. So I've got my front end, my business tier, my back end. So I've got my 3 tiers. But I've also got these other ones that we covered in another recording that talked about the Azure Firewall and the Azure Bastion services. So I'm going to come to one of the subnets that I have here. So I'm inside of the subnet. I've got my IP address information about it. I want to come down to the network security group. It's right here. And this is the one that was built at the time that I built the VNet itself. But I can now come in and I can now find that AZ-104 demo one. And so that's now the NSG group that's being assigned to this subnet itself. So I've now changed that. I'm going to cancel this, not save it. I'm going to create a VNet. And in the creation of the VNet, you'll see it under security. There's that virtual network encryption. There's the Azure Bastion firewall, some of the other VNets that could be built in here. I showed you that in my just example. When you build the VNet and you then configure the subnets, it knows that it's going to need NSGs. So if I don't have one that I want to have applied, it will automatically build those, because by default, when you build the VNet, it's going to have the NSGs for the subnets within the VNet that you're building. So in this case, it knows that it's got a subnet. It knows that it's going to need an NSG in there. It would allow me to get in and do that. And so if I come in and edit this default, it's in here that if I wanted to do something other than have it build the default one for me, I could come back in and said I want it to now use, in this case, my AZ-104 demo one that was pre-built. So whether you're doing this through templates, you can have a library of your NSGs and have them be deployed, or you can have it build one and then accept the default. So a couple of different ways to do that. Okay, let's go back to the closing. So we've seen that in networking, it's a fairly simple feature inside of Azure, but security is always a concern. In the past, you've had a limited set of tools to be able to deploy security inside of your networking environment that you've built. Typically, they were firewalls, and they have a cost that's associated with them. Inside of Azure, the Network Security Group is a free service that allows for some specific information, specifically ports and IP addresses, that you can now use to configure security for inbound and outbound traffic. So a great way to secure, especially that internal networking. Because it only does that limited blocking of specific ports or IP addresses, you might not want to use it in that public-private ingress, but I would strongly recommend that you deploy it across your network infrastructure inside of Azure. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.